all attendees in the Zoom meeting. If you have any questions throughout the call, just send in your chats in the chat box, and then we will be able to get to those sometime towards the end of the meeting. So if you have a question, just ask it now.
Alrighty. Okay, ready to start? Yes?
Yes.
Okay, good. All right, thank you. Okay, cool. Hi, everybody. So, yeah, my name's Austin Allen. I'm a mechatronics engineer living in Pasadena. I've got about 12 years of experience since I graduated from the University of Michigan in 2014. So basically, I was invited on here to, talk to everybody about engineering and as I described, talk about how to build a sustainable career, with whatever path you happen to choose. So I put together these slides just to first give myself a little bit of an introduction, and then talk about some of what I think are some of the key points about the type of career path that I had sort of built out for myself. So a little bit about my background. Sorry, I keep cheating. So about me. So originally I'm from New Jersey. I went to Rutgers University where I got a bachelor's degree in mechanical engineering. While I was there, I worked in robotics research for a professor of mine who I approached after class one day, and I just asked him if he needed some help with some of his robotics work in his lab. Um, Through that same opportunity, I also had started a NASA summer research fellowship. So it was basically the same work for that same professor, but it was sponsored by a NASA fellowship for the summer, which helped to open some doors later. The research subject that I worked on was basically detecting the slip of rubber objects for tires and robotic grippers and fingers, as they would say. And so it's a process that's called incipient slip. So it's basically detecting slip before it occurs, so that if you're gripping an object using a robotic gripper, then you want to hold it tight enough that it won't slip, but not so tight that you crush it. It might be something delicate. So incipient slip is one way you can go about trying to detect that if you can detect the process. So some of the skills that I worked on there included computer vision processing, so processing images and video, running experiments, collecting the results, and then helping to put them into a published research paper. So here were a few pictures of the test bed that I had basically worked with. For this one, it was a motorcycle tire on top of what's basically a treadmill, but without the treadmill, supported by three jacks, so you could set the plane. And so this was kind of my first exposure to, I guess, extracurricular engineering work, after high school. So this was in college, and this was after about 2 years of school there. On the right, we have a picture of this contact patch on the underside of the tire. So as it gets pressed into this piece of clear acrylic, you can see the edge. And here was some more of the data that I had collected, where basically I looked at the dots that were around the contact patch. And then what you can see is that the dots that are in blue are the ones that haven't slipped yet, but the dots that are in red have slipped. And so you basically see a slipping region coming from the outside in. And so when that slipping region gets sufficiently small, you get full slip of the motorcycle tire. And so that's why it's called incipient slip, is basically a pre-slipping happens of a patch that's not the total patch. So you don't see the full tire slipping yet, but you see bits of it moving. After that, I went to the University of Michigan, where I got my master's in aerospace engineering. I was originally in their PhD program. I stayed for 2 years, and then I left with my master's degree, which was fully paid, which that is an avenue for some people. It's kind of frowned upon, but if the circumstances, I guess exonerate you, then you can leave with your master's degree. And in my case, it just happened to be that way. And so that was paid for. The research focus there was on mathematical modeling of these sorts of novelty materials. So electromechanical materials for sensing and actuation. So you have electricity and you have an actual force, so stress or strain. So say, for example, you want to take electricity and turn it into something that can exert a force or that can sense stretching. And so that's kind of like where this electromechanical term comes from, is that you have this sort of a coupling between um, electrical properties and mechanical properties. And so between the two of them, you can do sensing or actuation, as I said. So you can apply electricity, make thing move. This is how it works. So some of the skills involved with that research in grad school were basically it's a lot of heavy math, and then incorporating that into simulation software. here's just a screenshot that I took from some old slide that I had put together, I think like 12 years ago or something. Don't really worry about it. There's a bunch of math, there's a bunch of symbols and moon runes. Don't worry about it. But so it was a lot of simulation type work, and so it was very research heavy, is what I wanted to get across. So, talking about my early career, after grad school, I worked in Boston at a company called Waters Corporation as a mechanical engineer. Um, and so, a lot of the skills that I now use for my work were related to mechatronics. So, mechatronics is basically controlling motors, reading from sensors, communicating between what they call microcontroller boards like Arduinos, which you guys might have used in your classes if you had exposure to that in school. So a lot of motor control sensors, collecting data from the sensors, simulating how the system will behave, reliability testing. So if you run this thing for 100 million cycles, when is it expected to fail? I did some custom machine learning at that time. So this was around 2017 or so. And so this was before, I guess, the rise of ChatGPT and LLMs as we know them today, like Claude and Gemini, if you guys are familiar with those. So it was custom neural nets that I put together based on this data that I collected in the lab. And so the idea was that you could build out a custom model to determine the state of the system that the company was selling um, by reading the sensors and processing them in a certain way, and then feeding it into this machine learning tool, which is a lot of word soup. So sorry to bombard you with that, but just to give you some background there. I also worked on high pressure seals and valves. They're called check valves. And so a lot of my work had to do with machine diagnostics and monitoring of those particular systems. And so I learned a ton. That was my first job. Worked there for about 5 years. And that's kind of where I gained my passion for engineering because the projects that I was working on actually began to work. And so, to be quite honest, through school, I never quite got that sense of excitement, where you'd actually work on something and then, you actually produce a result. And it was also work that I happened to be very interested in. So here's a quick animation of basically the pump system that I had worked on when I was at my first job. And so it's called a serial pump, serial actuator pump. And so you have one pump that's basically pumping fluid through this small channel, which is connected fluidically to this check valve, which is then pumped through by the second actuator. And so you basically have a motor on one end that's turning, and you have a coupling or a coupler. And so that turns your rotational motion into something like a linear motion. And so you're pumping through step by step. And so by synchronizing your actuators in this way, you can pump the fluid through at a steady rate. Um, so in the lower left of both of these actuators, we have a small device, and this thing's the whole assembly is called a check valve. But the piece of interest is basically a ball that's sitting against a polished seat. And so the idea is that it's so finely polished that it will actually create a seal, and you have to use very rigid materials in order to do that sealing for a number of chemical processing properties and advantages. So zooming in on that check valve, we basically have this, it's a sapphire. I'm sorry, this is a ruby actually. It's similar to sapphire, but it's ruby. And then we have a sapphire seat. Um, and so we basically have a very thin contact patch between the ball and the seat. And so here were just a variety of the check valves that I had sort of dissected and looked at. Um, and so a lot of the work that I had done there had to do with this is stuff that you would basically learn in undergrad, but you basically do an analysis of the ball and the seat, and then you can make some predictions about how the system is going to behave and how it's going to perform. Because what the customers were seeing was that the ball was getting stuck to the seat, and so you want to build out a mathematical model first in order to understand the fundamentals of the relationship between, for example, the width of the polished seat, which is this variable A, and then the contact pressure. And so you want to have sufficient contact pressure so that it will properly seal against the fluid pressure. But I won't get too much into that. Don't worry about the equations at the bottom either. And then this was just an extension of that into 3D. So again, no need to worry about it really. Just wanted to give some background. Some of the more interesting work that I had done at that same company was that we basically needed a way to detect how much fluid was inside of the bottle at the top of the stack. And so you have this fluid stack, and you have fluid that's running through these different modules. And so it first comes from the bottle. And so it basically gets sucked out using a tube. And so when it gets sucked up using the tube, you want to know how much is left because when a customer is running, if they run out of their, it's called solvent, which is the chemical in the bottle, then they'll complain because they'll say, why does your system know how much fluid is in the bottle? And so what I had basically proposed was putting a tower sensor array on the outside of the bottle. And so this was a machine learning type application. You have a number of these infrared emitters and receivers. It reflects at all these points on the side of the bottle. And then at the point of the liquid line, you'll see a sharp difference in the amount of light that gets reflected. And so it's an optical effect because of the presence of the fluid inside of the bottle. And so this was an idea that I had put forward and tested myself. So this is one of my test setups that was in the laboratory. So we have a solvent bottle, and then we have my little sensor tower over here with the sensors and emitters. And then I used a Raspberry Pi, which similar to an Arduino, which is something you might have heard of in your classes, is another type of, it's called a microprocessor development board. So it's not an Arduino, but it's something like a little bit more powerful than an Arduino. And then here is just some of the data that have come out. So you basically see over time as the liquid level surpasses each of these sensors, you see a rise in the readings over time, and that's all you really need to know from that. And so at that same time, when I was working my first job, I started to learn about Arduino and Raspberry Pi and electrical engineering. Coming from a mechanical background, I had to kind of teach myself. And so what that meant is that I burned a lot of components, which is bound to happen when you're first starting out. And as long as the components are cheap and you can get more of them, I see nothing wrong with going out and just trying it. And then you'll probably break a bunch of stuff. But that was basically how I learned. And so that was sort of how I sort of made my transition from mechanical engineering into more like electrical and mechatronics. Some of the projects I worked on included a robotic arm. I did a little walking spider bot, a quadruped. I did a quadcopter, which crashed into my living room. I did a LiDAR robot, which was controlled by an Xbox game controller. I did this ring position sensor, which was pretty fun. And that, again, used a neural network. So it was like a custom machine learning model with some infrared LEDs. Had some other random stuff. I worked at that job, as I said, for about 5 years. And then in 2019, I quit my job. And then I left Boston and I moved to Los Angeles. And then 2019 until now, I started a company called Elation Sports Technologies. And so what I was originally working on with no job and living off of savings and no community and no co-founders, I was working on a sports rebounder, which could basically detect where somebody would throw a ball and it would hit this net and it would bounce back to them. So you could use it as an accuracy training tool. And then COVID hit in 2020. And so I was living off of savings. Nobody was going to their sporting events. Nobody was doing any training or collaborating. And so I had no path to market. So I tried to make a Kickstarter campaign for a piece of this overall puzzle, which unfortunately totally flopped. So I was burned out. And then I went back to work for a normal employer at that time. But I later published the project as open source. And so I still have this company today, but I'll revisit that shortly. Here's a screenshot of the Kickstarter campaign that I did. And so just as a quick reference, basically Kickstarter is where you can try to raise, you can do what's called crowdfunding. And so you raise funds from a lot of different, just I guess, normal people rather than an institutional investor or like a venture capitalist type person with a lot of money in their pockets who's willing to give you a bunch of money. And so you can kind of raise small amounts of money from a lot of people. And unfortunately, yeah, this project did not quite pan out. But I later ended up self-funding this project, and so I do sell that on my website now. And so I've made, I think, something like 200 sales of this particular product. And so I was originally trying to raise money so that I could actually do the manufacturing to make these products and sell them. And I eventually did that with my own money. So later into my mid-career, so after my first job, this is about 5 years into my career. I worked for a year at a 3D printing startup called SprintRay, which is located in Glendale, in the greater Los Angeles area. And so basically what they do is they print ceramic teeth of all things, which I didn't know was possible, but apparently you can do that. So you can print teeth and dentures and mouth guards, and then a few other things like crowns. Actually, I forget if it was called a crown or a bridge, but it's some kind of a dental term. It kind of keeps your teeth in place, but you can use it to install the tooth. So I worked with their innovation engineering team. And so some of the things that I worked on included print quality measurement. So you want to tell if a part has failed or not during printing because it's what's called masked, it's called, DLP printing. So not MSLA, but DLP printing to be specific. So it's a certain type of printer. Some people call it resin 3D printing. So you have basically a vat of liquid resin and then you print up from the bottom up. And so we basically wanted to detect if the part had fully printed or not. And if it didn't, you would have maybe a layer separation or it didn't print properly. So I worked on that and then also improving the overall product reliability, adding in more, I guess, smart self-diagnostic features into the machine, things like that. Around that same time, I additionally began working for a fitness startup, which I still work for them today. Some of the products that I helped to design were this glute ham exercise accessory for their home gym platform. So basically, you place your knees on this mat and then you sort of lower yourself down, and it's a type of hamstring exercise. I additionally worked on the electronics for a heated massage roller, which was one of the concepts that we had designed in this company. And then the biggest product, which we're still working on trying to sell, is this plateless Smith machine. So think of it like a workout station, but it doesn't have any big plates that you put on a big barbell. Instead, it uses two giant motors that are inside of this cubby, and then you use cables that are attached to a bar with no weights on it. So that's kind of the idea. And then it was once again a Raspberry Pi, and you could basically use this touchscreen to increase the weight. And so that was the idea. And then this whole thing can kind of fold up. And so there was a mechanical engineer who did the mechanical design. Then I did the electronics and the user interface for the touchscreen. So around that time, after I left Sprint Ray, which was the 3D printing company, I worked at this specialty electrical components company that was in Alhambra. They later got acquired. They're now in Riverside. So I worked there for about 2.5 years as a senior mechatronics engineer now, where I helped to basically design the machines that would produce their specialty resistors. And so these resistors are basically used for detecting very high currents. So we're talking in like the hundreds of amps range for things like automotive, Tesla, SpaceX, Philips, for like medical defibrillators. So high power type applications. So I have to design those machines. Some of the in-house machines that I worked on were this go no-go machine. It was this optical character recognition machine for inspecting the labels on the parts as they get manufactured. I worked on this soldering station, two different types, so dual-headed and rotary. On the left, here's the go no-go label checker. And so basically it's once again motor control with a camera system. And so this also has a light on there. And so as this guy steps through, it would detect this sensor, which would tell if each pocket for each of these resistors inside this strip of plastic would move through. And so then a closer up view is on the right, and that shows the label as it's being read. And so this label read was insufficient. So the label was not printed properly. And so it was like an inspection of parts as they were created. Here's a picture of the rotary soldering station that I had helped to program. And so my contribution was really more up just on the electronics on the top and then some of the internal stuff. So we have temperature sensors and we have these different stations. And so the idea is that you put the parts that you want to be soldered onto these hot plates, and these hot plates have different temperatures. And so as you have the unit run through, it will automatically do what's called reflow soldering. And so it would heat up these parts at different temperatures along this given profile to make sure that it's soldered properly. That's all there is to it. Now, later in my senior career, 2022 until now, I've been working, doing a lot of freelancing work. And there's a huge text wall, but the types of things that I worked on include cinematography, hardware design. I've designed a fidget toy for one client, an industrial scissor lift with a giant battery, a pool kit chemical handling, so a lot of pumps. And that was like a 16 motor type control system that I designed. An aquarium filter mat roller of all things. I also do some physical event promotion in downtown LA with a promotion company, which is pretty interesting. I worked on some electrical e-bike electronics. There's sort of like a specialty component they needed in their e-bike. I did a motorized stroller pusher for one client. I worked on some unknown casino technology that the casino wouldn't tell me about, but they needed help with it. So they wouldn't tell me because if you know how the technology works inside the casino, then that'd be a big problem because then you can get a lot of money. So they wouldn't tell me what it was, but I did work on it. I've worked in the construction industry as well. Worked on a self-watering flower pot, a robotic eel, which was another strange government grant sponsored program, a wireless camera gimbal transmitter. I've done some custom cables. Another construction project here. I did this golf swing trainer. And then a race car driver speed reaction trainer, which I'm currently working on. These are kind of like very strange niche, subject matter. But that's the point basically of talking about all these things is that as you progress in your career, if you go along the career path that I had gone on, which started traditionally and then ended up into freelancing, you'll find yourself working on some really interesting projects. And so you get a ton of exposure to a lot of industries. And so that's kind of the point I wanted to drive home with this text block here. Here are some of the pictures of the products that I've worked on. The one on the left here is a circuit board that I designed for monitoring freeze dryers. This second picture is a sobriety count-up token, and so it's for somebody who wants to, for example, abstain from drugs or alcohol, or wants to stay on a diet. And so I designed basically this item which is battery powered, and it's got a little screen and a couple of buttons to navigate through to set your, set the settings inside of this guy. The next one is a what's called a diffusion panel, and so this diffusion panel was actually used on the set of The Mandalorian, interestingly. So it's the Star Wars show. And so I designed the frame for this. And so I'm still working with this company today. They were my first freelancing client. The one on the right is a gem fastening machine angle sensor. So this would basically be used for setting the angles for polished edges on the outside of gemstones, which was another strange, like I never thought I'd be working on something like that, but that's just kind of where you find yourself if you do freelancing work. I also did this fidget toy on the left. Here's just some of the other 3D modeling files that I had designed. So you do a 3D model file, you 3D print it, you design a circuit board, slap it inside, put a battery in, program the thing, and there you go. You've got a product. So, so that's kind of my bread and butter when it comes to making money. Basically, is that I do a lot of product design, so a lot of battery powered type devices, and a lot of them sort of follow the same design principle. Um, here's a few more items too. On the left here, we have what's basically a skee ball soccer machine. And so this was used as a promotion for the Bank of Montreal, BMO. You might have seen their offices around. So you basically kick a soccer ball down this ramp and then it slides into one of the holes. And then there are interrupt sensors that are, they basically can see through the hole. And so when it interrupts the sensor, it'll increase the score. And then there's a button to reset the score. And so it's like skee ball, but with soccer. And so this was a promotion for Bank of Montreal. This other device I was working on, but that project didn't come to fruition, was a smart air conditioner controller for avoiding high rate charges that utilities companies would charge, during their peak hours. And so that was to help avoid that. You control it using a web app. And then this was additionally another type of controller that I'd use for another project, but similar type of application. So some of the other projects that I've worked on include a motorized furniture dolly, which I've presented a few times, which some of you might have seen already. Another one is a long exposure LED wand. So you can basically draw out, over long exposure photography, and you can make drawings in the air at night, which is kind of fun. A Bluetooth shoes project, which I've been working on, which I can share a little demo at the end of this presentation if anybody's interested. And then these telescoping couplings, which I mentioned earlier in the presentation, and I sell these now on my website. So here is a quick video of, so basically I put together this YouTube video and I open sourced this furniture dolly. And so here's just a quick snippet of that video. And so what we basically have is in the lower right, it's a web app that I basically vibe coded. And so this is running on my Android phone. And so you can basically drive around this furniture dolly, which I slapped a seat on top of it to make a dangerous, very unsafe, no seatbelt go-kart. Or you could remove the seat and move your furniture around without having to push it. And so here's me sitting on the furniture dolly and driving this thing around. And so yeah, basically, okay, yeah, that's pretty much all I wanted to show. So that was kind of a fun one, and it's interesting working on the projects that you do. And this is a point that I make later in the presentation, but if you work on a random project of something that's of interest to you, it might so happen to be that you can actually find work later, like from your clients. And so this same project actually landed me my highest paying client for the industrial scissor lift one, because I saw this, sort of automated platform. That also landed me another gig with another client as well. So, it's interesting, where sharing your projects will actually lead you later in life. But that's something I kind of want to stress, is that if you want to work on something and you share it and people like the work that you do, then it can actually lead to opportunities later, even if it doesn't seem like it will at first, because I had no idea where this would lead. I just wanted to make this furniture dolly move around, and I thought it was funny. So I just tried to do it. So, some of these other projects, as I mentioned, include this Bluetooth sneaker, which I've been developing. And so this is basically Bluetooth enabled, and so you can basically control the lights on the shoe. And so there are light up shoes on the market, like Skechers. It's kind of one of the biggest brands, and they've been around for a long time, even since I was a kid. But this one kind of has a finer resolution of LEDs, and I also want it to be a running shoe that would be pretty durable. And this prototype can also collect information about your step rate and then the angle of your foot as you take each step. And so you can collect quite a bit of information from your steps. And so I've got a few other ideas of how to augment this too. Oh, darn. I put in here, I wanted to add a screenshot of the app to control this one, but I'll just have to show you in the demo. So pretend that there's a screenshot there. Don't worry about it. And then here is a screenshot of the circuit board that I had designed, which fits inside of this enclosure. It's got a battery in there, and then there's also space for wireless charging if you want to charge this wirelessly. But it's kind of an extra feature. Here's some of my other projects too. I know I'm kind of rambling at this point, but I've worked on a lot of stuff. Here was the sports rebounder that I mentioned earlier. It basically detects the landing position of a soccer ball. Here was the sort of, I guess, touchless position sensor. And so here was like some of the data that made a little GIF out of that. I thought it looked kind of funny. So threw it in here. On the upper left is the light writing wand. And so this is a long exposure photography photo. And so you basically use this one and you can set the colors to sort of draw things, and it looks pretty cool. Here is the circuit board that I designed. This was one of the first ones I had designed inside of the sports rebounder. It's inside of this little cubby on the back. And then here is a wireless transmitter for camera gimbals, which I actually am still working on, and I've got a couple of collaborators on that one too. Um, in 2024, I founded my second company with a couple of co-founders called Cinelux Cinema Tools. And so, again, this started because of a previous project that I had worked on with my with a client. And so he liked the work that I did, and so he pulled me into basically pulled me aside to start a company with me. And so I said yes. And so the first product that we designed was this LED ring product, which is again controlled using a Bluetooth app. One of our newer products, which we're going to be releasing our version 2 in June, is a motion picture film camera, which is modernized with a lot of nice newer features like a touchscreen and some other nice stuff that I can't really talk about because we need to actually share it first before I start sharing that stuff. Need to disclose it. We've got a patent pending on that as well. So my role at that company is electrical engineering and hardware design, firmware, software. Here on the left is the prototype that we had developed last year for the camera. And so we had a mechanical engineer, so he designed these aluminum parts. And then I did the electronics. So we have a touchscreen here and then a whole bunch of electronics in the inside, including motors that would make this thing move and run and expose the film at the right time. And this was our first company product, which was this light ring. So this, once again, was like a Bluetooth controlled ring. You take this and you put it in front of you basically put it in what's called a matte box, which is has these standard panel sizes. And so this fits in a standard panel size. And then you can bake lighting effects into your film set shots is the idea. So to go through the questions, and basically these were shared with me to sort of prompt and keep me on track for the discussion topic. So the first question I was basically asked was what sparked my interest in STEM. And so in high school, I basically had no idea what I wanted to do. I had no confidence. I had no idea what I was doing. I kind of had this vague idea that I wanted to do something related to engineering or robotics, but I really couldn't quite put my finger on it. I was really shy, very intimidated by all this, complex, electronics and mechanical design and stuff. Didn't know how to properly persist when it comes to developing an engineering project. But I had a programming teacher. He had a civil engineering degree, and coming into coming in to teach, coming in with a civil engineering degree, that inspired me because it showed that you can have a lot of flexibility in your career if you get an engineering degree. And so I said, okay, that sounds perfect. So that's exactly what I did. So I applied for engineering school and I got in at Rutgers. I applied for a few more schools too, but ended up going to Rutgers because it was closer and it was in state. And so throughout my schooling, it actually wasn't until after I got out of school that I didn't really find my real interest or my real passion in engineering because when I started to work on things that I was actually interested in, where I was not limited by studying for classes and courses and having to do projects that I don't necessarily care about, like a computer lab course or like some in-house lab course. Finally, I was able to work on things that really interested me, and so that's exactly what kind of sparked it for me. And so it led to a lot of personal growth, and it led to a lot of excitement for the things that I do. And thankfully, I had a boss who was at my first job who was willing to let me sort of run off with my projects, and so that's exactly what I did. And so I guess the point of this slide really is that 2 points. I guess the first one is that if you feel like you don't really have like a very strong passion for STEM or engineering, Basically hang in there and keep trying different things because you'll eventually find something that you can sort of vibe with and that you really enjoy. Because I know I did, and it took until after school for me to find it. Um, the next question is, was your path linear, and did it involve unexpected pivots? And so um, it was linear up until grad school. And so my path was basically go to school, do your homework, you know, do your extracurriculars. Like I was part of a running club, for example, and did ski club and tennis team and stuff like that. And so it was basically linear and on that track until graduate school. Again, I was in their PhD program. The PhD program was not really working for me, and I had the opportunity to change departments, but I left with a master's degree instead. And so that was the first pivot. And it was kind of, it was sort of by choice, sort of not by choice. I had an opportunity, as I said, to continue, but I decided not to. So that was pivot number one. The next pivot was at my first job. I was working very hard, but I wasn't being promoted. And this was after about 5 years. And eventually I got so sick of it, to be honest, that I quit and I moved to Los Angeles and I started my own company because I felt it was the right time to do that. Whoops. And then the third pivot was when my most recent employer was acquired. And so I was let go, but I had about a year to prepare and I kind of, could smell it was coming. And so I built up my freelancing network during that time when I was working at that company, and I built out a portfolio and my client network. And so the transition was actually quite easy for me. And so what I did was I basically just picked up the freelancing full time. And so I've been doing that full time now for about 2 years. And so I've got, I think at the moment, about a dozen or so clients. And so you basically just kind of juggle these different projects, and then that's how you can make money. And the vast majority of that work is all remote as well. So it's about probably 95% remote, and then maybe 5% I'd have to go visit a client or drop something off or, install something on site or whatever. What I'm expecting now for pivot number four is because, you can always expect pivots in life, is that probably one of these scalable projects, like the products that I'm developing and want to sell, will probably pick up some momentum and I'll be able to transition from hourly freelance to focus on that instead. So that's kind of like the path that I've been on up to this point. Next question is, how do you know when an idea is worth pursuing versus just interesting? And so the key here basically is getting feedback. And so if you have a notion for some idea that you'd like to try to develop, it's perfectly fine to go and develop it if it's just of interest to you. Like there's nothing wrong with that at all. I think it's a great way to learn. And that's what I did. But if you ultimately want to make money, you want to transition out of working for a regular 9 to 5 type job, then you want to basically transition into more of like an ownership position. And so you need to properly identify what people will actually pay for. And so the idea is that between engineering and marketing, they're both equally important. And at the cross section of both is profit. And so they both need to be fulfilled in order for you to make any money, because you might develop something really great, but if nobody wants to buy it, then you're not going to make any money. Or if you market something but you can't build the thing, then okay, it's just it's empty. You can't. What are you going to sell? Unless you lie, I guess. I guess some people do that, but don't do that. It's bad. So, um, oops, I'm like going through. Um, yeah, so basically the idea is that if you have an idea, build out a proof of concept, make it presentable. This is what's called a minimum viable product, an MVP. And you can learn about this in any sort of basic, startup book if you ever decide to read those. And so the idea is you want to keep your eyes open for opportunities or pain points where you say like, oh man, it'd be really cool if something like that existed, or like, wow, this thing that I'm working on is a huge pain, and I would really like it if somebody would fix this problem already. Those are the types of problems that people are more willing to put money into, because there has to be some sort of a vested interest there. So, what's a mistake that you made early in your career that reshaped your engineering journey? And so, I'd say the first one I honestly made was sticking around at my first job for too long. So, I know you guys are still in school, and so maybe it's not quite relevant to you yet. But once you graduate and you get a job, or you start a company, or you work for a startup, or whatever it is that you do, um, if you stick around at a company for too long, you risk missing out on better opportunities elsewhere, and that's a sad reality of a lot of employment these days. So the idea basically these days is once you work for a company, the rule of thumb is kind of to change jobs every 3 years or so, which it really shouldn't be that way because a company should reward you for sticking around, but it's not the case actually. So, whereas you would get maybe a 3% raise and barely keep up with inflation by staying at one company, you could instead maybe get like 8, 9, 10% raise just by making one jump to another company because they will overvalue your contribution and you set a new standard for yourself. And so that really is the fastest way to grow if you're working at normal employers. That being said, if you work for one employer at a time, that is risky because you could get fired. You put all your eggs in one basket and you heavily rely on this company, and now you're beholden to them to pay all your bills and support you. So, you face a lot of risks by working for one employer, and for some people that is the right move. But for me, I know that it was not. Once I learned how to properly market myself and do my own business. And so the idea is that you basically want to have some ownership of the company that you're working at, whether you have some equity or some kind of a revenue or a profit split based on sales, so that you could have some scalability in the returns that you get. So the idea is that for the amount of work that you put in, you want to get an outsized return. You don't want it to be the opposite way around, where say you work for a company and no matter how many hours you work, you will get the same paycheck no matter what. I mean, it's not really a scalable way to grow. And so that's why a lot of people who just graduate, they'll go and work for a startup. And that's something that I encourage you to take a look into it. And so if you know somebody or have an opportunity to be associated with a startup, then I do encourage you to do that. And so the only thing that was really holding me back personally when I had first graduated was I didn't feel confident. And so I didn't work on a startup for, the first like 5 or 6 years after, I graduated and had my career. So, but the idea is that the sooner that you start, the sooner you can kind of get over that hump and you feel more confident as you take on more work. Some people can go right out of the gate. And so if you feel like you want to give it a try, then I encourage you to do so. Um, the other thing I wanted to mention too was diversification. Um, right. Well, actually, no, I think I pretty much already said this. If you have multiple income streams, if you have multiple clients, if one of your clients drops out, then you could just, you can actually fire that client. I know it sounds odd. You think of employers firing people, but you could fire the client instead. If I don't know, they're giving you unrealistic expectations, and I've had to do that a few times, but it doesn't really it didn't sink me though, because I've got plenty of other clients I could just do that work for instead. And so it keeps things very calm where you don't feel like, you have what's called golden handcuffs where you're stuck, with one particular revenue source and you have to make it work. And so instead it's better to just spread it around. And the final thing I wanted to mention on this point is that in order to generate these opportunities, try to surround yourself with like-minded people who are also like you. And so people, for example, who share your beliefs, and your value system. And for me personally, I know that I value the entrepreneurial spirit, and I value having high agency and having a go-to attitude where you'll figure it out. Basically, that's the right mindset. And so Los Angeles does have a great networking community, and so I've provided some resources at the end of this presentation. If you want to go and check it out sometime. And I've had some undergrad students who would be a little older than you guys because you're in high school, but they came in, to come check it out, and they weren't even working yet. But networking is always a really, really great thing to do. So the next question is, how do you explain a pivot in a way that strengthens your narrative instead of making it look inconsistent? Um, and so the feedback I had in this one was that how others perceive your pivots depends on how they perceive you. And so if they view you as dependable and adaptive, then all your pivots are seen as a good thing because it's like, oh, there goes, there goes Austin. He's pivoting again, and that must be a good idea because he's smart. But if they don't believe in you, let's say, oh, there goes Austin. He's pivoting again. He's flaked out again. So the idea basically is to build up your credibility and illustrate that you're dependable. And so it's about building trust and accountability. And so you kind of want to be prepared for that, beforehand. That's kind of the move. And so you can't quite control how other people perceive you, where people might not believe your narrative. Like your narrative might be, oh, it was a pivot because it was strategic, but you want to kind of it's like the proof is in the pudding. So if you work on projects that are good and people approve of it, then they'll approve of your decisions. What project made you feel compelled to start something instead of joining an existing company? I founded Elation Sports Technologies because my sports rebounder concept didn't exist, and I wanted to see if I could do it. And so, same thing for the cinema tools. I wanted to create something new in that space, and so I just wanted to see if I could do it. And then it just so happened to be okay. It happens to be in products that are, people have interest in those, and so then you can make it work that way. The better way to do it, honestly, is to have a problem in the market that you want to solve, and then you work towards that instead, rather than building something and then hoping people come and buy it. Because I've definitely done that. So, but I also just wanted to note at the bottom here is that if you are the type of person and you want to create new things, then you'll see the most benefit if you start your own business. rather than sinking all of your time, effort, your blood, sweat, and tears into a company, for somebody at the top of the company to make an outsized return, and then you have no ownership of the company, and so you just keep paid salary. So you get a linear return, they get a nonlinear outsized return. So it's best to avoid that, but it's also acceptable to get some experience first.
Wait, so sorry.
Um,
Wait, hold
yeah,
on. For the sake of time, we might have you just skip to the last slide for the
sure, sure.
information, and we're gonna move on to the next segment too.
Sure, sure, sure. Sorry to drag this on. Yeah.
No worries.
Oh, yeah. So I guess that's basically all I wanted to say is just yeah, entrepreneurship is really fun. I encourage you to try it. That basically sums it up. And then here's some of my contact info. So thanks for interrupting me, by the way. I didn't realize I got over time there. Thank you.
No worries. So then, in the meantime, we can move on to our other three speakers. We have Sarah, Michael, and Michelle here, and they are all, they're here to talk. They're all first alumni, so they're here to kind of talk about or share their experiences and how maybe their high school experience in the first program shaped or benefited them in some way when they moved on to their future in career and education. So yeah, I think we'll start seeing Michael as a spotlight. So if we can get everyone highlighted. Okay, there you go. Okay, so I guess just to get started, you guys can go down from Sarah to Michael and Michelle and kind of just talking about like your background in first and then just like a brief like introduction, basically.
Yeah, hi, I'm Sarah. I joined first in 2015 when I was a sophomore in high school. And yeah, and I did first sophomore through senior year. When I graduated high school in 2018, I did my undergrad in mechanical engineering at MIT from 2018 to 2022. And from 2022 till now, I'm in a PhD program at Texas A&M working on robotics and mechanical engineering.
Yeah, hi everyone. I'm Michael. I also did first robotics. I was a graduating class from Wilson the year of 2020, and after that I went to UCSD for my master computer science degree. And during my time at UCSD, I also like do like a year co-op with a company called Becton Dickinson, a medical device company, and I went on to work on three different positions as platform engineer, full stack software engineer, and senior software engineer within that company. And I'm currently, going to start my master in Georgia Tech computer science program starting in October.
Hi, I'm Michelle. I did first robotics or like first since like middle school, and then I did FTC in high school. And I was part of the Axle-otl team, I guess. Um, and now I'm doing my undergrad in mechanical engineering and product design at MIT.
All for the introduction.
So I think we'll begin this segment by like asking questions. So this will kind of be more of a conversation style. So the first question is, what was the best takeaway from your involvement in FIRST, and how do you still utilize those skills today?
Sorry, do I go first? Okay, cool. Yeah, I think first was a great like starter for me to like learn how to like outreach and talk to other engineers. Um, it was like a really great introduction to to putting yourself out there and kind of reaching out. Like I think in like whatever college you guys go to, there's like more opportunities than like you're able to like do. So I think like first was a great place for like finding those opportunities because it's like kind of this gray cloud of like there's so many things out there. Like you have to like reach out and find the right people and find the right things. So I think first is a really great starter of like learning how to reach out, like talking to people who like finding the people who are willing to talk to you. Especially in high school, I think it's almost hard in high school to find people who are willing to talk to you. Um, but in like college, like everyone's like it's more open. So I think like getting a start and like learning how to outreach to people, I think was a really good thing I took away from first.
Yeah, I think for me, it's like, doing my day-to-day work as a software engineer and working on Pixis dispensing cabinet, which is the most used dispensing cabinet in the world. Like the design, even though as complicated as the design is, I realize what I do day to day is very similar to what I did at first, which is, you have the different requirements coming in. And for first, we have a competition. So first, a robotic competition, you always have like a goal you try to accomplish, and you're starting from that, and you come up with different design. and you evaluate, okay, what is the pros and the cons in the design, and you estimate the cost of each design, because each different robotic part costs different amount of money. And I think the best part from first I like is that you work in a team. So in a team, you have a team captain, you have the engineering lead who work on the robots, and sometimes you have the programming lead who focus on the programming. You have people working on the outreach that branch out the networking and community. And this is such a parallel to, like, one day you guys working a team in a company or a smaller or bigger company, is that you often don't work alone. You are often working a team environment. You have schedule, you try to hit, you have deliverables. And how do you position yourself to make meaningful contribution to a team? I think FIRST has provided a lot of opportunity like that.
Yeah, I would agree. I think there's like getting into robotics at a really early age taught me a lot of things that I like about the engineering world and what I don't like. And like, I think getting started early taught me that I like the mechanical engineering components. I like outreaching and networking with people, and I like the work that I do to feel really meaningful and impactful. And I think first instilled a lot of those values in me and the way that the program is designed. Yeah, so I would recommend doing it if you're interested in engineering. It gives you a really good taste of what you can do in the engineering industry. And yeah, like now I'm doing mechanical engineering at MIT, and I'm also like, I learned through the robotics program that I really like teaching. So I'm also concentrating in education at MIT, and I like taught abroad recently too. And all of that is really fun. I think the whole reason that I was able to like get into this and figure out what I like is through the robotics program.
You guys, so then I guess moving on from that kind of topic, do you guys have any advice you'd give towards students who might be in FLL or FTC, and some advice you have when they want to branch out or when they eventually go into education? Like what are some tips or takeaways they should have in mind?
Yeah, I think a really big thing is like taking initiative. It's pretty easy to like coast through like, in the program, like you guys can all do pretty well in the competition and like build a really good robot. But at the end of the day, like what you ultimately take away from these programs is like the soft skills you learn, and like what Michael said, like the people skills, right? Learning how to work with a team and compromise, and like, weighing out options like objectively. Because at the end of the day, like, yeah, you build a robot, that's great. Unfortunately, the like real world or whatever like is a lot more technical and complicated, but like learning like these skills of like breaking down a problem, like breaking out the design requirements, extracting like the core need of things, deciding when you are over engineering or under engineering, learning to work with a team are just like really core things that I think are skills you carry on beyond just like first. And I think like even if you're like not looking into engineering, I think it's like stuff that is like learning how to work with other people and compromising, I think is like a really big thing. Learning how to like step up for yourself and take initiative, like when you feel like your voice isn't being heard, I think is also like a really big thing. So I think that there's these like soft skills that I think are like really critical. Like I think you learn a lot of engineering, which is great, but I think that these like soft skills aren't like really taught. Like at college, like yeah, like it's taught. Like you learn engineering, you join teams or whatever, but there's no like formal like teaching of that like in college. And in college, like yeah, the technical stuff is all there, but I think the soft skills are what makes and breaks like you as an engineer and the progress of the team. So I think learning to develop that in a place that's like kind of safe-ish, I think, where everyone's trying to learn it, I think is really key.
Yeah, it's so interesting that what Sarah shared is exactly what I put down for what you guys want to take away today. Like the number one is take initiative. The number two is working with others. And I think the point of taking initiative is so important, is that today there's absolutely no harm in trying. Like when I first joined robotic, it was the summer before my junior year in high school, and I just moved to from Taiwan to US when I was like 14. So I started high school, bare not really knowing English. I was just talking to one of my teammates, Jack, at the time. He was like the judge that kind of judged me to see if I can make the trial or not. And he said that my English was not good, but I had a great passion. So that's how I ended up getting on the team. So if you guys are remotely interested in anything, doesn't have to be robotic, it can be cybersecurity, code, or Scioli or Science Olympia. Like just give it a try and see if you like it. And this skill of taking initiative is gonna be so key because once you get to college, nobody will force you to join any club. You are not joining club or doing anything for your college app anymore. I mean, you shouldn't be, but anyway, there's nobody pushing you. And once you graduated from college in your career, I think I really like what Austin shared about like if you become stagnant just in the same company for a long time, you're not really growing. Then there's so much opportunity cost along with that. So learning to take initiative, there's something you're interested, give it a try. And the second point that I share working with others is so key. So Jensen Huang, the CEO of NVIDIA, he shared that in this age where AI is so rampant, so smart. He said my personal definition of smart is someone who sit at the intersection of being technically astute, having human empathy, and having the ability to infer the unspoken, the around the corners, the unknowables. So I think what Jensen Huang shared is very true. The technical aspect, some like really difficult differential equation that would take engineer weeks or months to get around. Now you can just use AI software to solve it like in seconds. I mean, there are more nuance to that, but what I'm trying to say is, as you continue to grow your technical depth, either in school, either in robotic, in code, whatever, it's very important you continue to elevate your soft skill. And for you guys, the best way to elevate your people and soft skill is to work in a team. That can be joining robotics team, joining the code team, or joining the cybersecurity team, where you have to put yourself in a position where you have to work with others, and your people skill not going to improve in one day. It's gonna through years. So the earlier you start now, the more advantage you'll have.
Yeah, I would agree with both Sarah and Michael. I think it's important for you to get to work with people as early as possible, for like long periods of time and to like make progress and go through design processes with people, understand where different ideas come from, how to like figure out which ideas are the ones that you want to pursue. Like all of those things I think I learned well on the robotics team. And I took a lot of that into like the classes that I'm taking and the projects that I'm working on. I think engineering is a very collaborative field, and if you don't learn how to collaborate with people, you're very stagnant. And yeah, like take opportunities as you get them. I think I learned how to do a lot of like organizational skills through robotics, like hosting events like this or hosting community events, getting in touch with my community. I don't think I would have been able to do any of those things had it not been for like the program that I'd been in. And so I think it's a good way for you to put yourself out there and for you to try things that I don't think you get to ever really do in your classes.
That was our great advice. I think one of our attendees have a question for Michelle. Mentioned earlier that through FTC, you found out like what you don't like about engineering, and like how did that help you decide what you didn't like?
Yeah, I think for me, I really didn't like coding. Like I hated the programming side of things. And I learned that really early on by trying to do it and realizing that it just sorry. It just didn't click for me. And so I realized that I like more of like the mechanical engineering side. But even when I was doing that side, I wasn't that involved in the like actual building of things. I was more involved in like the community side and working and making things for the community. And so that's what I figured out what I like. And so a lot of the things that I do now are more like design focused and working with the community. So like I'm taking a class in something called the D Lab, which is like global development, and I'm making like products for places in like South Africa because I've learned that I think like global development and community impact is really important to me, and I learned that through robotics. And so I think that like through like the things that I did on the team, figuring what I liked and what I didn't like was helpful for me and like help speed up the process of like knowing what I wanted to do in college.
Yeah, I think what Michelle said is so important because you ever think about engineering, like any engineering product in the market, let's say, for me, I work on the Pixis drug dispensing cabinet. You need people in the legal department. You need people, in the sales department to market the product, and you need like actual clinician that interview the nurses to get the customer need. And Austin also mentioned, very important to know your customer and what people need. And those are like not necessarily engineering skill. Those are people skills, and you can still contribute meaningfully to any product. Not even though like, and your engineering background definitely gonna help. So yeah, joining a team, trying out different things in robotics. There's outreach, there's programming, there's engineering. So like trying out all different things and see what you like, what you click with. Like Michelle said she hated programming. I love programming, but I kind of don't like building robot and working with electronics. So like that's kind of how I figured out, okay, I'm going with computer science degree in college instead of an engineering degree.
Yeah, so here's one last question from us. So I'm sure you guys all lead very busy lives as like engineers and software engineers. So how do you guys prevent burnout?
I think, yeah, generally, like, I think burnout is a really big deal. I think it's pretty easy to be like, yeah, if I could push every day, I'll get whatever I need to get done. I think like surrounding yourself with like, this is like kind of a thing where like maybe MIT wasn't the best place. I think surrounding yourself with people of different majors. Fortunately, MIT is all engineering majors, so you don't really get that as much. But I think that like surrounding yourself with people of different majors, so you get like, I don't know, different perspectives of like other people. Like I think is like something like you could see. I don't know, like I think widening your view beyond just like the engineering world. I think burnout really just happens when you're like kind of tunnel vision in this one thing, right? I don't, for me at least, like I don't really get burnt out like if I spend a lot of time doing a lot of different things. But like if I'm like hyper focused on this one thing for like 14 hours straight, then yeah. I think yeah, setting boundaries, like the lab that I work in right now, like it's like I'm a grad student, but like I very much kind of constrain myself to like the typical 9 to 5. That not being said, like I do stay like later or whatever. But I think like setting some type of boundary and like setting some schedule seems to work for me really well. And yeah, finding like hobbies like outside of engineering to like kind of work different aspects of your brain. And I think like yeah, meeting people from different like majors or whatever is really cool. Um, like I like crocheting and knitting, and that's just like something I could do like kind of head empty, just do it. Yeah, but I think like I felt like I was a lot more burnt out in high school than in college because like what Michael said, it's like you can kind of like high school. I feel like you're trying to max everything for your college app. College you get to choose a bit more, which is like harder and easier. You could choose too many things, but then you're like half doing everything. But if I feel like if you choose a fewer things and you dedicate your time to it, and these are things like you are now actively choosing, not for like college apps. You could say you're doing it for resume or whatever, but I think it's yeah, I think it's just like the fact you're able to choose and balance that a bit more. Yeah, yeah, I think that's all I have to say.
Yeah, I feel high school is kind of like, so hard. I think high school is one of the hardest time because it's like you're trying to do so much for the college app. So I think sometimes what it helps is like you need to feel really passionate about like what you're doing if you're gonna commit a lot of time. And this advice I kind of tailor to the high school because you guys, I think no matter how you optimize it, you're gonna have a very very full day and a lot of time. You get to choose, but also to an extent. But when I remember, like, I was up 3 a.m., before the competition start in one of the members' garage and like programming robot, and Miss Lam was like, "Hey, Michael, is the robot done?" And like I was like, I was happy. She was like, cheering me up at 3 a.m. build like writing program for the robot, and I didn't feel burned out just because I had so much passion, like trying to win the competition and trying to build the best program I could at the time. So I feel if you guys can, not just, oh yeah, I'm a robotics, I do science and Olympia, so on and so forth, but like really pour your heart and soul and energy into a goal. So and then you're working on it, you feel fulfilled doing it. But as you grow older and then going to college, you have a lot more choices. Sarah's advice of setting boundaries and choosing Instead of choosing a million different things like in high school, choosing the thing that really matter to you, that you really enjoy, that's gonna benefit your career, and a lot of the other thing that's not as important, you have the opportunity to not do them. And that's like the long-term mindset. But I think short-term, for you guys situation is just really invest in it. Don't just, oh, I'm on the team, versus, hey, I'm glad to be part of the team.
Yeah, I would say like the very same thing as what Michael was saying. Like, unless you like something, it's not really worth doing it. I think in high school, you get very caught up in the idea that you have to do a bunch of different extracurriculars. But like, the truth is, like, it matters. Like, what matters is what you get out of those extracurriculars that you're doing. And so, if you're going to a bunch of these club meetings and you're just going, spending your lunch there and not doing anything with it, you're not learning or gaining anything from it. And I think that those like silly, small little tasks that may feel like they're not, like, they add up and they take up a lot of your time and they take up a lot of your energy. And that's what's burning you out. Like, for me, whenever I was really burnt out in high school, it wasn't from doing like robotics. It wasn't from like staying late doing robotics. It was from like things that I didn't want to be doing or things that I didn't like doing. Um, and I think that same thing happens like in college. I think the most burnt out I ever was taking the Intro to Python class because I hated it so much and I didn't know how to code. But then once I started doing classes that I liked doing, like I could spend hours doing it. And I think for me, like it was helpful to be friends with people that were my major because like we could all work together and study together. And that was a really fun environment for me that made me feel less burnt out if we were like all working really late into the night. Um, and I did that a little bit in high school too, like working on AP exams with people, and that was fun. But I would say that like to prevent burnout, like really think about what you're using your time with and think about if it's worth it. And like I don't know if people are like applying to colleges now, but like I did piano for like 12 years or something, and I spent a lot of money and a lot of hours doing it, and I hated it, and I didn't ever play piano again. And I barely wrote about it in my college apps, and like all of that time like really burnt me out, but like it never ended up being something meaningful to me because I just didn't connect with it. But like the things that I really spent time with and I really enjoyed doing, I talked a lot about in my college apps, and it was like the focus, like robotics was a big focus of my college apps. And so like think about that, like think about how you're spending your time because when you're like passionate about something, it's easy to spend that time there and I feel like you don't really get as tired of doing it. It's like fun for you. Yeah.
You see, thank you. Thank you guys for that advice, I think. Now I think we can probably move on to the actual Q&A portion. So I'd like to invite Austin Allen back to like the floor, to the spotlight, and then maybe you can answer some questions since we did get some in the chat. This is also a good opportunity for the other attendees in the Zoom. If you guys have questions that come up, just feel free to ask them. We'll try to get to all of them if we can. Yeah, so I want to get to this question we got earlier. They asked, do you have any advice for balancing extracurriculars, school, and other responsibilities? So anyone can answer this question.
Yeah, I think to try to piggyback on what Michelle shared, right? So two things we have shared, you should be passionate about it. Sarah shared the importance of setting boundaries. And I think I would like to add this, like, a lot of this pressure you're putting on yourself at high school of trying all this extracurricular is because you want to get into a good college. But I want to shift that premise a little bit. Your goal, your ultimate goal is employment, a job. Your ultimate goal is not getting into like the best college ever, because you can go to like, I don't know, if anyone's philosophy or public relation, you can get to UCLA and be like a liberal arts major, or like you to go to UCLA for whatever philosophy major and you're an engineer, right? It doesn't quite help. So I think the point I'm trying to make is that you guys really think about what do you want long term, and like what is it that you're really interested in, and invest time there. You might not, you don't need to go to the best school to have the best career. College is like just only 3-4 years of your career versus your career is like 30-40 years down the line. And my brother is sitting across from me. When I thought of my brother, he went to Cal State Fullerton, which was not his best expectation because he tried so hard in high school, but he recently got into Wells Fargo for investment banking, which is like top 1%, in the top 1% of like acceptance rate, which is highly competitive. And I think for his case, right, it's like my high college was not his ideal, but he had what ended up a really great career start. So I use his example to let you guys know you don't need to put so much pressure on yourself that I don't get into the best college, I'm done. No, college is just a step board to get to what you really want in your career. So if it's not the best school that you hope for, that's okay. And don't burn yourself out doing all the thing that you don't really care about just of like 1 or 2% better chance of getting into a good college.
Thank you. Does anyone else have anything to add? If not, we can move on to the next question. Okay. Okay.
Yeah. So the next question is, what if I change my mind about what career I want to go down in college? Is that too late?
I think there are like very like core things that like I think just good people that are working have. I think there are like some skills that like, and I don't want to say it's too late, but it is like you'll probably just graduate later, usually is what it is. Um, like I have friends who like switch from like aero astro mate again MIT. So there's not any other really majors, but they like, switch from like aero astro to like computer science, which like maybe isn't the biggest gap, but like she honestly graduated early, which is kind of crazy of her. But I think it's like never really too late to get into engineering. I think the one thing about engineering that's like like I feel like like lawyers slash doctors, like you need to go to school for that, right? But like yeah, like what like Austin Allen, like his experience, like he was able to develop like so many skills like outside of like the typical school, like like he was able to develop these skills like outside. There's like so many resources online, right? But I think there are like yeah core things of like yeah, are you curious about it enough? Like are you willing to go dive deep into it? That I think applies to almost anything. Yeah, I think like the only like majors that like have that kind of more time requirement is like law school and medical school. But even then, I know people who like joined that late, that like are able to just like start their career a little later by like 2 years. But what Michael said, your career is like 20, 30 years. So like we're going from like 20 to 22 years. Like what's that gonna do really? But yeah, I think yeah, I think like high school is like a great place to explore. But at the end of the day, like you have to take classes. You have to like like there's like so many constrictions that you don't get to fully explore. So college is a really great place to also explore. I know there's like, financial, all that other stuff that plays into a role, but I don't think you should ever be scared of like wrapping, like changing majors because you're going to be stuck with that for like a long time, right? So like you want to be able to like explore, see what you like. I think like a lot of clubs, like I know like a lot of engineering clubs also need like a business person to manage that. And then like maybe like you start there and you could explore that side. Like I think there's ways to like kind of like navigate through that a bit more. But I think the people skills is really big. Like no matter what like industry you get to, people skills are really big. And yeah, like the taking initiative is like always going to be really big. Yeah.
Yeah, I can also add to that. Like I know someone that went into like did all of biology related things in high school and then got to like MIT, took like one mechanical engineering class and like totally switched up his major. And I think like high school gives you a very small taste of what a field looks like, and college is like a little bit more taste of what that major or like that industry looks like. But it isn't until like you actually get to start doing it that you realize what it is like. And so I think things like your interests are going to constantly evolve and it's never too late to change what you're doing. I think a lot of people start off doing engineering and then become like management or become like business or like take on totally different roles. And so like never feel like it's too late to start doing anything. Like even if you have no idea what you're getting into, like the important thing is that you have like a love and a curiosity for learning. And I think that skill takes you a lot further than having more experience in a certain field or major.
Austin Allen, do you have anything to add from like that type of standpoint and being in the career?
I don't know, just wanted to mirror what everybody else said. And the key word here, I think, is yeah, taking initiative and having high agency with your life. So yeah, I think if you change your major after 2 years, I mean, the alternative is to take another 2 years. So that itself is an opportunity cost. And so yeah, if you change your major, maybe it's not ideal. Um, but as everybody has said, your career is much longer time span than that, and yeah, I think if you decide that you want to change your major, then well, I mean, okay, so maybe you're on like year three, and then like, you only have one day left until you graduate. You don't want to change your major then. You shouldn't do it then. But for any other case, where it's only 2 years in, yeah, I think it's okay. 3 years in, then maybe you can maybe think about it just to have like a backup. But 2 years in, I think is fine. Anything less than that's all right. But yeah, the alternative, yes, you get a major, or I'm sorry, you get your degree in something where you might not want to do that long term. And if you know you don't want to do it, well, now you're going to suffer for 2 more years because you don't want to be on this path, and so yeah, it's going to be horrible. So yeah, it's not too late.
Thank you for that. Okay. We also have another question. This is more first program related. It asks, how has FTC helped you get internships or jobs? So like in any way, I guess.
Yeah, I for me is like I think similar to Michelle, all I wrote about on my college app is robotics, and I got like the scholarship I've got at UCSD. All I wrote about is robotics, and once I get into like, you know, UC San Diego, it's like I joined clubs similar to robotics where we have working toward a project, and then we're working a team environment. And for my first internship, you know, getting that internship, all I talk about is the team I did at college, right? And but I think the reason I can do those type of kind of engineering based club at college with ease and with a lot of confidence is because I already did it at high school. And so yeah, so I think indirectly it helped me get my first internship. And more importantly, I don't think of robotic equating internship. I think about robotics equate, building the foundational skill of people skills, communication skills, and as well as some technical astuteness that help me open up opportunity for me in the future, regardless of what the opportunity is.
Thank you.
Yeah, there's another question that asks, what is one risk you took in high school or like in your career that paid off?
I can answer that one. So for me, it was, yeah, taking the full jump into entrepreneurship. Yeah. Of course, as I showed earlier in the presentation, yeah, I had to do it twice to make it stick, but ultimately ended up being worth it. So yeah, I'd say that was probably the risk for me. Yeah.
I wouldn't say it's a huge risk, but I honestly wasn't super, yeah, like convinced to join robotics. I kind of did it because it was like my friend was also trying out. Um, all of that to say, like, I think just like don't be scared of trying things. Like even like I wouldn't say it's a risk, but like I just was like, I guess like we'll see. And then the year I applied, I think there were a lot of people that were applying. Um, so like, and I just like got lucky or something. I don't quite know. But yeah, I think just like trying stuff out and seeing what sticks, I think is just like you should always be trying to do that. And if it doesn't work out, I think again, like don't be afraid of changing it up. Like I don't think if I like decided I didn't like robotics, I don't think anyone would have held it against me if I was just like the next year I'm like I'm gonna step away. Um yeah.
Thank you. I think me and Leon laughed because it's quite relevant to our experiences too. Because like we went into high school not like with a clear path to do robotics. I know she also tried out because her friend tried out, and I just tried out on a whim as well. But yeah, we kind of found that it was a good experience, but that was only after trying it out. So another thing, I guess we'd all emphasize that take initiative and like be proactive and try out that new thing because it might end up being your thing down the line. Um, I think we also have another question. It was, how did you learn to handle failure? So this could be in any capacity, I guess.
Yeah, I think failure is the perfect opportunity to grow. And I feel like, why is taking initiative hard? Because you're afraid of failure. I think for a lot of us, even myself included, that's often one of the friction point. So I think the way is really just understanding, every failure opportunity is a chance to grow. And I think one word, we that has been mentioned a lot is opportunity cost, right? What is opportunity cost? Opportunity cost is, okay, today I try robotics. Okay, it doesn't work out for me. Then that's fine. I just don't join the robotics team for the next semester. But the opportunity cost of not trying it and turn out for me if I didn't do that tryout, then I wouldn't develop my passion for programming. I wouldn't have, gone into the club in the university, which then got me my first internship, then got me my first job in the company I'm staying at now. So I think you can see like all those opportunity costs if I didn't, you know, try robotics because I'm afraid that my English was not good enough. Or, oh, I'm already about to be a junior and I don't know any programming. I'm not the best prospect to be at a tryout. If I let those things kind of hinder me from trying, then there's a huge opportunity cost that would have been associated with that decision.
Yeah.
Yeah. Oh, sorry.
Sorry,
Um,
I think that's
yeah, I think, sorry. Yeah, I think there's like almost like two ways to look at it. I think a huge part of like the reason you don't get the internship or get into like X college or do that is like honestly, like I feel like if you're willing to accept that like a lot of the world is kind of very luck based or unluck based, I think that like not taking it super personally is something that like is just kind of something you have to accept. Like for example, like the lab I'm in currently, like just timing wise, like pure timing wise, like my advisor was looking for looking for students. But if I joined a year later, he wouldn't be looking for students and like I wouldn't have gotten that opportunity. That doesn't necessarily mean that I was a failure. Like it's literally the same person, just a year later, right? Or even a year before, because he didn't exist in that school a year before. I'm accepting undergrads for internships. And like literally there are undergrads that are more qualified than other undergrads. But I'm like, I don't have enough work for a really qualified undergrad. So I'd rather take a rookie undergrad that I can have like an adequate amount of work for. So there's like so much like luck involved with like things like internships, college acceptance, like timing of things. Um, that I think that taking failure personally is almost just like it's not like you as a person. I think like the bigger failure is like what Michael said, like just not trying that opportunity, right? Um, yeah, like so much of timing, like so much of life is just like timing and um yeah, like just like how like the world around just happens to work. That I think that if you go into the like mindset of like even like failure after failure, like I think or like failure is not the word, but like yeah, just unluckiness, I think. But I think if you go into the mindset being like, I'm just gonna keep trying, like I am a lucky person, like just manifesting that almost for yourself, I think is like a better way to look at it. There's also like failure that like is kind of on you, right? If you like don't study enough for a test, like you're not setting yourself up for success. But I think like a lot of the failure you see like that is like I am a failure or whatever is like mostly just like luck based. I feel like I got like they're like yeah, I feel like maybe one day like someone didn't read my resume and I didn't get that internship or whatever. Or they decided like 2 days before or something weird like that. I think that just like not shooting your shot, I think is kind of where like the bigger failure is. Yeah.
Yeah, I think I want to build on that because I feel Austin shared about, what I like to call it the richness mindset, like resource versus mindset, right? Today, I gave the analogy that's relevant to you guys. I don't get into college, good college, I'm done. No, it's not black and white like that, right? You can go to maybe not the best college, but really work hard there and look out for opportunity until you find a career that satisfy you. And let's say internship, right? Okay, I don't get this internship. Well, there are so many other internship out there. It's not just that one internship. You can continue to apply. Always have other options. Don't bet all your egg in one basket. It's like, okay, no lab. This lab, if I don't get in this lab, I'm a failure. I'm done. Life is sad. But okay, if I don't get into this lab, what are some other labs I can apply for? What are some other internship I can apply for? Or grad school options even. I don't go to industry right away, or even gap year. You have so many other options. So I think a lot of time people get stuck just because they're like, oh, it's binary. But life is never binary.
Yeah, thank you. I think we'll do one more question. What is one piece of advice you wish students or parents knew before starting their journey in like engineering, innovation, robotics, etc.?
I think like going into college and like honestly like I feel like a lot of reasons I've held myself back was like purely like imposter syndrome. Like I think that that's just like a huge thing. I think especially like in engineering, especially like your first year, like in engineering or in college, I feel like everyone feels imposter syndrome. And so everyone's trying to like almost like peacock themselves and be like, oh, I know, blah, 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 blah. And like compared to like other schools that have so many more resources, like yeah, like I didn't like have machining experience. Like the what is it called? The Project Lead the Way, like did not exist when I was there, or like was just starting to exist when I was there. So I think that like I like held myself back a little bit. Like I like was like, oh, maybe I'm not smart enough to join this club. Maybe I'm not. So I think that like going into it like with like almost just like even like now, like sometimes I go up to people in my lab like and I feel like I also like now approach like other people with this. Like I'm like, most people don't know things just because they didn't have the opportunity to learn that. So if I like kind of go with that mindset, I'm like yeah, maybe I don't know how to design like X and X or whatever, or like code this. Like if I approach it like I just never had the opportunity to learn that. Like how would anyone expect me to learn that if I never had the opportunity? It's easier for me to like ask someone that question. And then now like as other people come to me and like sometimes someone's like, I don't know how to use a 3D printer. And my first thought, maybe my initial reaction is like, how the frick do you not know how to use a 3D printer? But like if I am able to change my mindset with more empathy and go like, oh, like literally no one showed them how to use a 3D printer. How are they supposed to magically conjure up this information? So I think engineering, it's a very intimidating field. I think just empathy for like yourself and like the others around you like makes a huge difference. Um, and I think if you approach it that way, like I think it can be very inherently competitive. But I think that like the best teams that I've worked on have been people who are like not afraid to like show their cards of the things they don't know and show the things that they do know. Like I think it's like the most like the worst teams I've been on is like everyone trying to be like, oh, this person like I'm the smartest engineer, blah blah blah, and I'm not going to try to show my cards of I don't know how to do electrical. So then they tell you that they know how to do electrical, and now we're like with a terrible electrical system, and you're like, damn it, why didn't you tell me? I could have helped you with that. So I think just like being willing to have empathy for others and yourself, I think is like really big into going into this field, but also being aware that some people don't have that. So you kind of have to have kind of a thicker skin sometimes in some scenarios. But I think it would be better if everyone was just like I don't know, vulnerable. Like not everyone like has opportunity. I don't know. Yeah. So yeah.
Okay, I think if that's the last answer for the question, we will probably begin wrapping up the seminar. Thank you so much to everyone for talking. I was wanting to see if you guys could probably drop your emails into the chat, so like in case the attendees want to see or like try to contact you later on.
And our team will also drop our own information and email and contacts if you want to contact our team as well.
In the meantime, is there any last words that you guys might want to share to the audience before we close the entire meeting out? Could be anything.
Yeah, absolutely. I have a lot to say, but I think like yeah, I think it's one thing is knowing how great you guys are doing. Like I'm in the robotics judging almost every year, so every year I get to see like new people joining robotics and how they're doing. I'm always You guys don't notice it because you guys see each other all the time, but I see the robotics team member like another year. I was like, wow, they have improved so much. So I think it's very important to recognize the progress you have made. It might not very immediately clear to you, and like Sarah said, like comparison is a thief of joy. So don't, because some people are really good, and like I'm surrounded with talented engineers, like a lot of them from Microsoft and Google, and like I work with them, and I'm grateful to have someone who know what they're doing, and to learn from them. And some of them are around my age and super competent. Just develop the mindset of humility to learn from others, because the most successful people in the world are the people that continue to get feedback and continue to learn. They don't just pretend they know everything. So my piece of advice is continue to learn and recognize that you're great, and don't compare yourself to others.
Thank you for that. Does anyone else have any more words they want to say at the end of this to conclude? It could be anything as well.
Yeah, I think
I think
like good luck. Oh, sorry. No, you
good,
could
good.
end it. I don't have. I was
Okay.
gonna just stall stuff.
Okay. Yeah, I just basically wanted to reflect what everybody else had already said too, and that's that if you are interested in something, just go for it, and or like give it a try, and you've got nothing to lose by trying. And yes, sometimes there will be people who will, maybe pass judgment on you, but they're not going to get very far. That's the real lesson to be learned, because those kinds of people who judge too much will face basically invisible barriers that they won't even be aware of. It's like if they hadn't been a jerk to you, then maybe you guys could have collaborated someday, or maybe they would have, not rubbed that person the wrong way. So eventually it all comes around. And so by being a humble person, and willing to learn and open, then yeah, you'll get much farther too. And yes, also openly admitting what you don't know is totally acceptable. And there's always a way to deliver that message to you. You can say, I can do all this other stuff, but I can't do this. And if you say it the right way, then nobody's going to say, "Oh, well, why don't you know?" No reasonable person would judge you for that. So it's okay not to know everything, and it's also okay if basically to get started. And that as long as the system that you build out is good enough, it doesn't need to be absolutely perfect, but you strive to get it better. That's all.
Thank you. And then maybe last words from either Sarah or Michelle before we wrap up.
Yeah, I would say to always like keep an open mind, especially like with yourself. I think when I was doing robotics, I wasn't doing much of the mechanical engineering work, but I always just thought it was really cool and fascinating. I loved the brainstorming process that we had. I love like designing with the rest of the team, even if I wasn't actually making those things. And so like going into college, I didn't have that much actual hands-on mechanical engineering work or like in the same way that other members on our team did. But I think I still went for it because I thought that it was a really cool field. And I continued to take classes that were very hard for me, that were like difficult to keep up with. I continued to like come up with designs that are bad at first and then become better over time. And I think it's important to like keep an open mind and think that like just because I'm not good at something the first time I'm doing it doesn't mean that I can't be good at it eventually or I can't learn from this experience. And I think that mindset and trying to like push myself to do things even if they're uncomfortable for me to do at first has helped me find things that I really love doing. And so it's important to like keep an open mind with anything that you're doing, whether it is the engineering field or whatever else you want to pursue. Like you don't have to be good at it all the time for you to do it. Yeah.
Thank you. And then if Sarah, you have any lasting comments you want to add as well.
Yeah, sure. I think most people here are mostly students. I think at the end of the day, um, just know that engineers are like, especially like two students, like just like yapping. Like we just like to hear like we like I think if you reach out to like a lot of engineers and be like, what are you doing? As long as it's not like private, like secret equity, whatever. Like we just love yapping. We love like talking about the stuff we're doing because we just love usually like all of us like love it so much that we're like super open to talk about it. And as students especially because like usually when it's like companies there's like conflicting interests, but as like students you guys have like this very unique opportunity and like time in which like like we are happy to like pour like our knowledge and whatever we have um like into like you guys, I guess. I think that so like don't be afraid or intimidated to reach out. Like there are times where like they won't reply, their inboxes are busy or whatever, but like I think like I personally had to like review a bunch of resumes for summer internships and I get like 300 of them. But honestly, if one person like emailed me about it, I probably would have taken that person, right? Like taking that initiative. Um, I think just like not being afraid to be like, hey, like I see that you're working on this. It's like a big thing in first, right? To like kind of like gracious professionalism, like sharing with others. And like, I think that's like the key part of like engineering that I think um, makes or breaks like a team and like people is just like being able and willing to share. And yeah, like I think reaching out to engineers and being like, how'd you implement this? And they'll like rant about everything that they've done wrong over like 2 years. And then they'd be like, but this is what I did at the end. And you can just implement that thing. But I think like even that can be like for like, career development. Um, but also like, be aware that like what they want and what you want are maybe not all necessarily the same. But yeah, I think like not being afraid to reach out to like professionals or like people in college. At the end of the day, they just like yapping and that like sharing the stuff that they're doing, because yeah, like we're excited about the work that we're doing, and we'd like to share that. But yeah, good luck. And yeah, y'all are like so far. Like I didn't attend a seminar in high school at all, so I don't even think, yeah, I didn't host a seminar, I didn't attend a seminar. I just was kind of YOLOing it, I guess. But so yeah, y'all are so ahead, and I think that yeah, exploring this avenue is like really awesome.
Thank you so much. And I guess on that note, I encourage everyone to reach out, I guess, with all the contacts that are in the chat. Probably if you guys could put, like save the emails now so that when the meeting closes, I think the chat will disappear too. So you guys can, yeah, check out all those emails in the chat. And any inquiry you guys might have for the attendees, just ask away. I'm pretty sure everyone here is pretty willing to answer a question or two again, if you guys have time, of course. And then for anyone that would like to watch this meeting back, our media team is also going to try to compile this entire meeting and then post it on our YouTube channel. And that YouTube channel is listed in the chat. It's at Axle-otls 26504. So just our team name and number. And yeah, so I guess that pretty much concludes today's seminar. Again, thank you all to all the attendees, Austin, Michelle, Michael, and Sarah, for coming and like joining with us and chatting and just sharing your experience overall. I think it was very helpful, not just to the attendees, but I think also for me and Leon to just listening. But yeah, thank you so much, everyone, and hope you guys have a good rest of your day.
Thank you, everyone.
We'll be ending the meeting now. Thank you.
Thank you. Bye.
Thank you.
Bye, guys.